Welcome everyone. I am Hyderwali Alamkur and my teammate is Safia Sheikh. Our project is Conway's Game of Life, an interactive web application. So we have uh, it's an interactive web application. So the project presents a web-based implementation of Conway's game, which is uh, developed and automated by John Conway in 1970. So we incorporated this project using PHP MySQL for secure access and leverage using React JS for real-time component-driven updates of the grid state. So the goal is to demonstrate both theoretical underpinnings of cellular automata and practical techniques. This is a We have a background and motivation for the project. So Conway's Game of Life is often described as a zero-player game because its evolution is determined solely by its initial state, requiring no further input. Despite its simple rules, cells live, die, or born based on neighbor counts. Complex emergent behaviors arise from oscillators and gliders to chaotic, unpredictable formations. We choose this project to explore how simple local rules can generate rich global phenomena and to apply web technologies to visualize and interact with such systems. Our objectives are interaction visualization, real-time simulation, user authentication, pattern loading, game controls. I'll go walk through one by one. So in interactive visualization, we have used grid-based UI and we have toggled using cell states by clicking. For the real-time simulations, we have used the React JavaScript to React.js to manage state and re-render only and the necessary parts of the grid each generation ensuring the performance. The user authentication, we have implemented a secure login page and the registration and the session management using PHP and MySQL, restricting access to registered users. Pattern loading allow users to select and load predefined patterns, example block, glider, gosper, glider, gun, etc., to study known behaviors. Game controls offer buttons to start, stop, advance, and next generation. We have a button to jump to 23 generations and reset the simulation with another button. So the technology stack we have used is front end, and in the front end, React.js for component-based UI, use state, use effect, hooks for state and lifecycle management, plain JavaScript for game logic fallback. We have used styling, backend, database, and hosting. For hosting, we have deployed in locally MAM server and demonstrating LAMP stack integration. For the database, we have used MySQL, stores user credential with hashed passwords, ensuring data persistence and security. I'll walk you through all these, the website and the PHP my admin by my teammate Safia Sheikh. So in the backend, we have worked on PHP scripts, handled user registration, login, and logout. Session management secures user page. For styling, we have used visual friendly and CSS for layout, the flexible layout, grid for responsive design, inline styles for dynamic cell state. For the system architecture, we have used the client browser, server PHP, database MySQL, and static assets CSS JavaScript. The separation ensures scalability, maintainability, and security. And we have gone to the next slide of the technology stack. It's the front end philosophy we have gone through with the game of life evolves in real time. And why we have used React is because of the components whose state reflects the world when state changes. React reacts by updating the view, and we have used HTML, CSS in the structure and servers and databases. The authentication flows works something like this. The registration, if you go to registration, it will direct to the PHP, and then the password is hashed and user inserted, rewritten to the login. Once you registered, you can use the login button to login. Without we have it won't author any non-registered users, and we have access controls of using index.php files and logout PHP session calls. And we have handled users with clickable cells, and for non-React portions, fallback or script.js attach on on-clicks listeners directly to DOM elements to toggle CSS classes. And the game controls, we have start, stop, next generation, plus 23 generation, reset, react, use states. So each has different. So begins and interval. So and this is also the in on the website. My teammate will walk you through all these components. And we have rule of codings, the local integration, global behavior, and survival, death, birth. In the metaphor, it rules resemble ecological systems, competition, overpopulation, and reproduction. Discrete versus continuous inside. Though time and space are continuous in nature, Conway's game shows discrete models can capture complex dynamics. So from here, my teammate will take up the approach of React versus, and she will explore you through the databases and the domains.
Okay. So the main reason which we have used React is so that it would describe what the screen should look like for a given state, and the React handles the updates. Whereas using the JS is an imperative method, and it will manually manipulate each cell, like micromanaging every step rather than setting up the system. And some of the modern paradigms are React embodies the idea that UI is a function of state and reflecting mathematical notions of functional mapping. So to optimize the performance, we've used the computational efficiency, which is basically only the necessary computations maintain responsiveness, much like minimal modes in science. And we've used the selective updating. So the analogy is basically focus on the regions of interest rather than reanalyzing everything. And then for balancing the fidelity and speed, we have used the higher resolution increase realism, but demands more resources. So for responsiveness and accessible design, we've ensured that anyone, regardless of device or ability, can explore emerging complexity, and we have a responsive layout and all the principles are accessible as well. And we have also done testing and validation for our whole code. We performed unit tests, integration tests, and performance testing for various functions like get live, neighbors, next generation, and so on. So the development of the code and the setup is basically like we've used a MAMP server in which we have placed a project inside the htdocs, which is inside the application of MAMP, and then we've configured a database, and then we've used the PHP myadmin to create the tables of users, and we've accessed this site using the local host. And I'll show the code which we have built. So if you observe, we've developed various files, like we have all the PHP files and HTML files. The code starts at the home.html. In this, we can see all the, if the user wants to, this is the first page which the user sees. They can either log in or register. If they're a new user, they'll first register and then log in. And once they log in, they'll be able to play the game. And these are other various files in which we have the patterns, how the grid would react, and the script.js, the styles, and we have various PHP files. This handles the SQL request, backend request for login, logout. If a user wants to register, we will also save the sessions of each user, and all the database information has been um, stored over here in the MySQL, and these are the other files. So whenever we first go to our home.html, this is the first interface which we will be seeing. They can either log in or register. If we register a player, demo 2, and once we register, it goes to the login page. So once the user logs in, we can see that the user is demo 2. And here we can see a lot of other components like start, stop, next gen, um, summation of 23 gens, reset. And here are various patterns. We can choose our own pattern, or we can choose from the patterns which are already preloaded. And then once we click on any pattern which we want, and then we can start, and our Conway's game is updated in real time. This is because of using the react.js file which we have. And I would also like to show the load pattern. Here we can see based on the neighbors which live and die, the game works, and it is updated in real time. And the user can log out as well. And we have also implemented the number of generations as well. And this is our SQL Server. So we have created a database Conway game in which we have a table of users in which all the user player names are saved. So the demo2 player and then email and the password, all of this is saved in the backend password, backend SQL Server. So the performance is basically the speed of adjustments and real-time React optimizations. And for our future works, we are thinking about the enhanced patterns, which will allow the users to define and save custom patterns via user UI. And I would also like to show one more update which we have done. So if we see in our game here, we can see the generation and the population. And once I choose this one, we can see we can also interact with the game in real time. If I have a cell which is too far from the neighbors, it would obviously die. And if it is closer to it, then it would get into the cluster of generations. And I can move to the next generation, which would be incrementing here. And then if I click on the plus 23 generations, it would be incrementing over here. And then we have the populations, and we can reset the whole thing. And also in our other future works, we're also thinking about the AI generated patterns, which is basically like using the ML to generate novel automation patterns and making sure to store user grid states in the database for lateral retrieval. And if you look at the code in the index.php, which is basically the code of the game, here we can see various buttons, which are like start game, stop game, next gen, and all the other things. Here for block, we have various kinds of predefined blocks. And then this get element by ID handles all our grid container generation population. And then for each function we have, it would either create the grid, it will toggle the cell, it sees if the neighbor is alive or dead, and it sees what's the next generation is. It would update the grid. And these are just the functions like stop, start, next gen, and next 23. And then these are the patterns which we have used. And here we can see all the patterns in the JS file, like block, both, B3, Gosper, and so on. And this is the main part which would be used as our real-time configuration, which has the function game grid, use effect, and all of that.
Yeah, thank you so much, Safia. So, yeah, could you please help me with the PHP database, right? So I'll just explore more on it. So, in the PHP, we have created multiple databases here for to log in with multiple users. Uh, multiple users. So, thank you, Safia. So thank you for muting yourself. So this is the PHP My Admin. We have multiple users here, multiple databases we have created for local and um, the hosting for databases also. So on this, I just want to walk you through this. So on concluding, could you please go back, Safia? Yeah, on concluding, we have built a fully interactive, secure, and performant web application of Conway's Game of Life, demonstrating the power of cellular automata, modern front-end frameworks, and back-end integrations, and the databases. So, thank you for your attention. Uh, so, this was the game and the work we have worked on the project 3. Uh, uh, then we have thank you so much, Safia, for putting efforts on the backend integration. Safia worked on the backend integration and the little front end. So we have collaborated the sprints in different sprints with both front end and back end and the database designing. So databases designing is completely worked with Safia. Thank you so much, and thank you for your attention, everyone.